Okay, so we started with problem number 2, and this problem looked familiar for you because it's similar to the example that we had for the relative velocity equation from last week and the using of the IC center, of course. And we're going to repeat it once again here, but we need to find the a new parameter, which is going to be the acceleration of the piston at this instant where the AB is going to be in the position shown. So you can see that in addition to the omega that we had last week, we have the angular velocity has been given to us now. Okay, so we have 200 radians per second square is the omega of that link. That link omega is 2.43, okay, for the BC, and the omega for the AB is 10 radian per second. Now, you remember that from we got this omega from the velocity question, and remember that we got the velocity at the point C as well if you want to go back and use it. So we're going to start to do the solution step by step. We start first with defining the AB is going to be rotation about the point A, and the BC is going to be general plane motion because we're going to have the IC once again and start to do the work. So we start to have the free body diagram for every link, and that's what we're going to have for the AB. That's the AB rotating around the point A. We are going to have velocity at the point B, and we're going to have two components of the acceleration at the point B. One of them is going to be tangential, the other one is going to be normal. And I think that you remember the equation for that. You don't have to memorize it because I'm going to write it down here. Okay, but it's going to be a good idea to write it down on your cheat sheet. You're going to use it for the next quiz. Now for the link BC, we know that the velocity at the C is going to be perpendicular, vertically upward at the point C. That the velocity that we calculated last time, and the acceleration at the point C is going to go the same direction. It's been given the direction for the omega BC in the question to be counterclockwise, and now we can actually import the direction of the normal and tangential acceleration we have for the point B and the velocity at the point B exactly at the point B here. So we know the angle here 13.6, and we can now know what will be direction of the ABN and the ABT and the VP at the point B. Now, by knowing this direction, we know this omega, we can find the alpha of the BC. We can write down the relative velocity equation. The known being given here that the alpha AB is minus 20 K. Okay, the alpha of the AB is minus 20 K. That's given the question. It's to the clockwise direction with 20 radian per second square. The omega of the AB is minus 10 radian per second, and the omega BC is minus 2.43 K radian per second. So now we, of course, the units for the one for the alpha is going to be radian per second square. Now let's see what are the unknowns in this question. The unknown are going to be the ACX and the ACY. The ACX is 0 because it's only moving vertically, so we're not going to have any horizontal acceleration. That's what you can obviously see from here. The acceleration here is going to be 0, and that's why we wrote down here 0. And we need to find the ACY. So the equation we're going to apply are first, we need to find also the alpha of the link BC is unknown. So we need to find it by the same equation. So the work is going to be done first. We're going to analyze the link BC, okay, to find the acceleration AC, the link AB to find the acceleration A, the omega AB, and the omega and the alpha of the AB link, and thus we're going to be able to find the acceleration at the point B, the omega BC, and the alpha of the BC, which is unknown. So for that link here, we're going to write down the relative velocity equation, and let's try to find out what we have and what we don't have. Now the alpha AB can be calculated. If I know the alpha and we know, sorry, the acceleration at the V, I can find the tangential and the normal one because I know the omega and I know the alpha of that link, which is going to make it easy for me to calculate them. The alpha BC is unknown. The RC/B can be found because I can make the analysis, find the height, and find the horizontal value. The omega of the BC is given, so I'm going to have it here as a scalar value. The RCB, once again, we said is going to be available for us. Now let's take a look to the link AB and find out what can I find out of it. So the acceleration at B, which is going to have a normal and tangential value, is going to be equal to the acceleration at A, which is 0, of course, plus the alpha AB, which is given, multiplied by the RB/A, which is given, okay, and minus the omega of the AB square that given, multiplied by the RB/A. So we know that this value is going to be equal to 0, and I can start to do the solution. So let's go back to every triangle individually and start to do the analysis, just to find what will be the x and the y value for every link. So for the link AB, is going to be equal to the RBA XI, that the base, okay, which is going to be very easy to be found because I know that the length of the link is 0.25. I know the angle. So this one is going to be 0.25 times the sine, the cosine of 45 is going to be negative because it's going to go to the left, and the RB/AY is going to be the 0.25 multiplied by the sine of the 45. Okay, so the x is going to be I, the y is going to be j. Now for the RCB, you can see once again that we have a triangle. We know this angle, so we can know what this angle is. Again, the y direction is going to be 0.75 multiplied by the sine of this angle. And for the x direction is going to be the RC/B, which is 0.75 multiplied by the cosine of that angle. Now we're going to substitute that in the both relative velocity acceleration equations. Okay, we don't put any number yet. Now we can substitute them as a number to find the answer. Now, just to remember that by doing this calculation, we're going to find out that this one is going to be the normal velocity at the point B, and this one is going to be tangential acceleration of the point B. Okay, so you remember that we said that the the normal acceleration is the alpha multiplied by r, and the tangential is going to be the omega square multiplied by r. So now this is going to be solvable because we have almost everything in it. And when I'm going to find the value for the AB, I'm going to substitute in the other equation and substitute whatever I have, and I can find what will be the value for the AC in the y direction. So solve, put the parameters in, everything is given to you, and you should have that the alpha BC and the alpha AC, and the AAC is going to be given as 27.7 for the alpha BC, that's radian per second square, and the AC is going to be equal to 13.6 meter per second square. So I encourage you to solve that yourself and find these answers.